Hi, welcome back. We've got just 2 more diagnostic steps to go, and in this segment we'll cover step number 12, checking the engine's mechanical condition. I have once again called in some outside help, and I am pleased to welcome David Drake of our Tenneco and Walker team. David, tell us what to look out for in terms of overall engine condition.
Joe, the easiest way to determine an engine's overall state of wear is to think of it in its simplest terms. An engine is really nothing more than a complex air pump. We understand that air enters, along with fuel, during the induction process, is compressed and ignited, and then expelled during the exhaust cycle. We can tell a great deal about the condition of an engine's key mechanical components by measuring its efficiency, or how much air is passing through it. If volumetric efficiency is low, chances are you have some mechanical engine work to do before you can correct an emissions problem.
How do you measure the engine's volumetric efficiency?
The best and easiest way is through the calculated load performance indicator on many modern scan tools. This PID monitors the mass airflow reading and then, based on the throttle position and RPM, determines engine efficiency at a given load. So as a prerequisite, you'll want to make sure your mass airflow sensor and all induction components connecting it to the engine are in good condition. You need to conduct this test at idle and then again at full load. At idle, the calculated load might be only between 5 and 12%. If it is much higher than that, you'll probably have cylinders that aren't contributing much, and others that are working very hard just to keep the vehicle idling. Near the red line, at wide open throttle, the calculated load should be close to 100%. A low number at high RPMs is a good indicator of a mechanical problem, such as worn rings, valve train issues, or an intake or exhaust restriction. The last step is to subtract the first number from the second, and the difference is your overall volumetric efficiency. Most engines are not 100% efficient, but for the majority of naturally aspirated engines, your overall reading should be 85% or higher. If it is lower than 85%, you're probably facing some internal engine work, and you must correct these problems if you're hoping to get emissions back down to a legal level. To double check your results, or if your scan tool doesn't support the calculated load PID, just calculate the engine efficiency by multiplying the engine's volume times RPMs and comparing it to the mass airflow reading. Keep in mind that volumetric efficiency will be lower at higher altitudes.
Interesting stuff. Thanks, David. So there you have it, step 12, and just 1 more to go. Please join us in our next segment as we complete the 13th and final step in the emissions diagnostic process. Thanks for watching.